Continuity equation in physics is an equation that describes the transport of some quantity. It is basically a stronger, local form of the conservation laws, and it asserts that quantities that follows the conservation law are locally conserved in a given region, and it cannot teleport from one place to another. Hence, it can only move by a continuous flow. A continuity equation is a mathematical way to express this kind of statement. Let's consider a conducting region bounded by a closed surface S that has a volume charge density ρV, and the current leaving the surface is described in terms of the current density J. The total current crossing the closed surface in an outward direction is described by the contour integral of J dotted with ds, while the inward current, characterized by the decrease in the current or in the charge concentration, is negative dq over dt. The rate at which charges leave the surface is equal to the rate at which the charge is diminishing in the bounded region. Therefore, we can equate the inward and the outward currents. And the equation we arrived at is called the integral form of the equation of continuity for currents. We can also get the point form of this equation of continuity by using the divergence theorem and rearranging the derivatives. So now we have the integral and the point forms for the equation of continuity for current. The integral forms are most useful when dealing with the macroscopic problems, while the differential forms are strictly local. They deal with charge and current densities and fields at a point in space and time. And any continuity equation can be expressed in an integral form, which is in terms of a flux integral, which applies to any finite region, or in a differential form, in terms of the divergence operator, which applies at a point. The integral form implies that any charge or any change in the charge in the region must be accompanied by a flow of charge across the surface bounding the region. And the point form implies that changing the charge densities are the sources of current density. The equation of continuity is a mathematical expression of the law of conservation of charges, and it states that the amount of charge or electric charge at any point can only change by the amount of electric current flowing into or out of that point. For a conducting medium to sustain a steady current, there can be no points of changing charge density, and current density must be constant. And if the volume bounded by the closed surface shrinks to a point, the integral may be interpreted as the summation of the current is equal to 0. This equation is basically the statement of Kirchhoff's current law, or KCL, which states that the algebraic sum of all the currents in a given point in a circuit is 0.